Hey, what's up, neighborhood? um, this is a book that I have. Um, I have not read it all. I'm not boasting. Um, excuse me, I have to cough. Um, I was, for a short time, a student at Johns Hopkins University studying data science, and this was going to be the textbook for the next class. I didn't take the next class. I only took one class at Johns Hopkins, and the next class would be an optimization. And optimization is kind of like the backbone of data science. If it wasn't for optimization, you wouldn't have like Chat GPT. You wouldn't have facial recognition without optimization. No facial recognition, no engineering. All requires optimization, and this is theory and practice. And the theory is complete. I mean, there's nothing incomplete about the theory. So it gives you all the theory you need. It gives you no theory that you don't need. And practice. So it brings out several fucking examples from engineering. It's very in depth. And it's probably almost realistic, actually. I don't know what realistic means. Anyway, this is the guy. I would be so proud to have written a book like this in the fourth edition. And I don't usually pick this book up, but it's a good book. I've put some markers in here. I unfortunately spilled coffee on it. That sucks. But by and large, I've kept it in a good condition. I'll sell it for $1 trillion, and I have a lot of profit. Um, so it starts with the introduction to optimization. Um, So the first step in like when you're doing an applied science type of mathematics is you want to classify problems as something or another. Like in differential equations, you classify them as linear or nonlinear, um, ordinary or partial, meaning one variable or more than one variable. Um, so they're like defining the problem of optimization so that and they're classifying optimization problems because this is basically a cookbook for how to get optimization done. And the table of contents is like, and you can see it's really boring, and there's like an obvious pattern. But although it is boring, and because they are using exactly the same motherfucking words on every line, except the last part's different, they're trying to show you that this is all like built on the same like mathematical architecture. So why not admit it, you know? So this is the theory, and then like I haven't read all of it, but let's see. Nature of equations involved. Okay. 19. Let's look at that. Um yeah, I remember it's the kind of book I would have like chopped my left arm off for when I was in high school. Um 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 all right. So the first step in any like new applied maths endeavor is classify the problem, because then there will be basically a flow chart. If the problem is XYZ, then here's how you solve it. If it's ZYX, then here's how you solve that. And then by classifying it, you bring yourself closer to hopefully an applicable solution. And one thing that I don't like about education in the public right now in America is one thing they don't really tell you in education is that whatever real life means, um, you know, I don't know what real life means because I sit on the couch, but real life to like engineers like this, this is meant for engineers. And what was I gonna say? I don't know. I just think this is, let's see. I had a purpose, but I've changed my mind. So this is when I was researching the Hessian matrix. Um, I just I know now that I've learned a lot since I graduated. Like when I was at Berkeley, I never knew the concept of Hessian matrix. I never knew that the Hessian matrix is what you use to quickly determine if something is an ideal minimum or maximum without any further calculation. It's called the Hessian matrix, and if it's positive definite, then that indicates a relative minimum, and if that matrix is negative definite, then that's a relative maximum, and that's an extension of the second derivative test in first semester calculus. So in first semester calculus, this would be called the second derivative test. Um, but in general, it just so happens that in this case, the Hessian is the second derivative. Um, and that is a matrix. The Hessian matrix is basically formed by taking all derivatives of all functions and, with respect to each variable. And if that matrix is quote unquote positive definite, then that indicates a relative minimum that you found. Because when you use these algorithms that they teach you, you'll get basically not a solution, but you'll get like a list of candidates, and you want to quickly determine whether those candidates are minimum or maximum. Because all you get is candidate. Like you don't know if they could be minimum or maximum or neither, which is called a non-stationary point. No, a stationary point or something like that. And this is the Hessian matrix right here. You'll have to excuse the vibration. I have a hand tremor. And I think this is about Lagrange multipliers. Yeah. I first learned about, I would say Lagrange multipliers should probably be taught in the second semester of applied calculus or the third semester of regular calculus. And I learned this in 1995 is when I learned this. I think every Calculus 3 student learns this because it's so elegant and it has a nice geometric motivation for the method. The method works. The method works because of the geometry. You can prove it all works, and basically it turns a hard problem into an easier problem. And yeah, so like here it says they state a problem with two variables, x1 and x2, and one constraint. So let's say our objective is to minimize f subject to the constraint g of x1, x2 is 0. That's just a constraint, hard to explain, but basically it'd be like saying your budget is, $1 million. That's a constraint. And it's also called an initial condition in a larger sense, or I think, I'm not sure. So they go on, and it's just page after fucking page. It would be a really bad idea for me to read this at night because this kind of shit would keep me up all night long and without a problem. And I don't, know all these facts, but I certainly could read every page I wanted to without problems. There's no notation that I don't know. I don't know where they got these pictures from, but I'm pretty sure these pictures are drawn by hand, not by machine. And they're very good, but I'm pretty sure they're by hand. I'm not absolutely sure about that. Not that anyone cares. And then at the end, so I'll sell this for um um since it's mine, and you know you will then own my engineering optimization book. I'll sell it. Oh, it is fourth edition. I don't know what edition they're on right now, but given the fact that this has 10 minutes and 47 seconds and no viewers, I'm gonna stop here.